you to understand the basic ideas about filters. You won't be responsible for filters here, but you will be responsible for the integrated quiz regarding the filters and some integration between filters and Z transform. Okay. So let's move on. Why do we use filters, arkadaşlar? Why do we use filters? What do you understand here? Filter, it's a system for altering signal in some useful way. What do I mean by useful here? Please write to chat. What do you understand from useful? A useful way of changing. Altering means changing the signal. How do you change the signal in a useful manner using a filter? Block unwanted signals. That's what Muhammad Zubair said. Getting some data that I need. It's Iqbal said. Nurefshan, what I need, what I want to know. Cleaning the signal. Take out unwanted signals. Eliminate signals. For us to use certain range of frequencies. Analog to digital or amplification. To detect important data in the signal. So we are trying to change the frequency content of our signal, right? That is entering the system. This is one thing that we are doing in filters. So I will also mention some other applications. It's also related to the frequency content, but there will be different applications of filters, like something that we want, or keeping something that we want, or removing something that we don't want. So these are the two things mainly the use of filtering. Okay. So you remember that we usually talked about linear time invariant systems, linear shift invariant systems, and the filters might have different gains for different frequencies, and you may have different systematics for filtering tasks. Okay, so let me ask, finite impulse response. Why is it finite impulse response? Why do we call FIR filters as finite impulse response? Does anyone know? Manal, do you know, for example, why do we call finite impulse response?
I don't know, maybe because the output is finite?
Output of the filter is finite, that's what you think?
Maybe be the impulse response.
Yes, maybe the impulse response is finite.
Impulse response is finite. What do you mean by finite? What does finite mean?
It's not infinite. It has...
Not infinite, right? Güzel. Finite means it's not infinite. So this is a finite sequence, for example. This is a finite sequence which goes from 1, 2, 3, 4, or 4 like that, right? This is a finite sequence. So my impulse response, H of n, will not be going to infinite. Is that what we are saying? Yes. Okay, H of n is not infinitely long. It has a finite length. Okay. What do we mean by no feedback? Why no feedback means finite impulse response? No feedback means I have y of n on the left side and x of n on the right side, okay? For example, if I have this n minus 2, what is my h of n?
Dirac n.
Dirac n
Dirac
plus
n minus 1.
Dirac n minus 1 plus Dirac n minus 2, right? So what's the length of this sequence? 3, right? 0, 1, 2.
0, 1, 2. So this is a finite length impulse response. Finite length impulse response. And there is no yn minus 1, n minus 2 on the right side. Okay? The output is only dependent on the input. If that's the case, we call it finite impulse response or FIR filters. Neymiş arkadaşlar?
The output is only depends on input. Yeah.
The output depends only on the input. Current input, 1 previous input, 2 previous input, 10 previous input, but it only depends on the inputs, okay? If my impulse, if my system y of n includes y of n minus 1 plus y of n minus 2 plus x of n plus x of n minus 2, for example, then this has a feedback. Değil mi? What does feedback mean? The previous outputs are used, let me write it here, the previous outputs are used in the calculation of the current output, along with the input samples. Okay? Do you understand this term arkadaşlar, this definition? I need to find out the current output, şu anki çıktı, current output, by using the inputs, current input and previous inputs, and previous outputs, output samples, okay? That's why it has a feedback. I'm using previous knowledge. Hani feedback, for example, I'm doing something and asking you, was that useful? And you say, no, hocam, don't do it like that. Then I use this feedback in my new application. Anlaşıldı mı burası arkadaşlar? So I am doing something and then using that something information in my new approach. Similarly, I'm using previous outputs in order to determine the current output. Is this part clear arkadaşlar? Everybody got the idea? Easy? Yes? Very nice. So that's why it is like with feedback now arkadaşlar, when I talk about IIR filters, I will not be able to put h of n instead of y of n and determine the impulse response for IIR filters. So y of n is equal to h of n and x of n is equal to Dirac n is valid only for FIR filter applications. Okay? For IIR, I cannot do it because I have here the previous h of n minus 1s. If you think about that, like h of n is equal to h of n minus 1 plus h of n minus 2 plus Dirac n plus Dirac n minus 2, right? I change this thing into something like that. Now I cannot directly find h of n. I have to do an iterative solution. I have to start from somewhere, like I will first assume these, then calculate, let's say the second one, let's say n is equal to 2. I will start from n is equal to 2 and say 0, 0. Then I will start calculating h of n in an iterative manner. Basamaklı şekilde, iterative manner, okay? I will calculate one, then go to the next one, calculate again, go to the next one, calculate again. That's why it is not possible for me to determine IIR filters by using this one, okay? It is not possible like that, but it is possible with FIR filters. Anlıyor muyuz arkadaşlar? Two things that you should be careful about. FIR doesn't have any feedback, only depends on X values on the right side, Y values on the left side. And for the infinite impulse response, there will be both Y's and X's on the right side and Y of n on the left side. Okay? So what does that change in our filtering applications? I will talk about that in coming hours, okay? So finite impulse response in MATLAB, you can use FIR1 or those kind of things. Okay, for IIR filters, there is specialized functions like that, like Butter, Chebyshev, elliptic, or design IIR filter kind of applications. But before designing an IIR or FIR filter, you have to know what it is doing. You have to know, why do you get those outputs? Why is my signal affected by this filter like this? You should be able to comment on it. You should be able to interpret it. Değil mi gençler? Isn't it important? Like you are building a filter using op-amp, but you don't know what it is doing. You just check, you find a resource on the web, and you put it on your breadboard, or you put it on your LT-SPICE application. But you don't know why I'm putting this R, why do I'm putting this C, what is the effect of changing R or C? If you don't know these, there is no point in coming up with a filter design that you're doing. Because if something changes, you won't be able to comment on it. Okay? If you are able to comment on something, if something changes, what will be the output, then it means that you are learning something. Okay, that's why when I show you something like that, I'm telling you, if this is the case, what would you do? If I'm changing this like that, what would you get? If you're able to answer these, then it means you're learning this topic. Anlaşıldı mı arkadaşlar? Peki. Şimdi bakın, I talked to you about moving average filters. Here is my impulse response, 1/2, 1/2, 0, 1. I can show it like this arkadaşlar, 1/2 in curly brackets. If I put 1/2 and 1/2, it means this is 0th term and this is the first term. Okay? So if I want to write this, I should write HL of n is equal to 1/2 Dirac n plus 1/2 Dirac n minus 1, right? You can go from here to there, right? Or from here to there. It's easy. Değil mi arkadaşlar? Yapabiliriz değil mi bunu? Şimdi, how did I go from here to here? Do you remember this step? Nasıl yapıyorduk? We determine, bu neydi? E to the power j minus j0, right? And this is omega. So I find the middle point. Hatırladık mı burayı arkadaşlar? Why am I finding the middle point? Because then I will say e to the power minus j omega over 2. Okay. In order to find 1, what should I do? E to the power j omega over 2. If I multiply these, what will I get? E to the power j0, which means 1. Do you know what? Why do I get e to the power j0 being equal to 1? Biliyor muyuz arkadaşlar bunu? What does this mean? My angle is 0. My angle is 0. My amplitude is 1. So this is a real number and it is 1. Bakın, this is angle. This is amplitude. Benimle miyiz arkadaşlar? Benimle misiniz? Ne yapıyorsunuz? İyi misiniz? Arkadaşlar, Ali Sait, her şey yolunda mı?
Yes, hocam, no problem.
Yes, you are following me or
Yes, I'm trying.
you are not sleeping, değil mi arkadaşlar? It is becoming dark. But you are the new generation, dark generation. You like dark nights, evenings, you know. It's better. Evet. Peki. So I want you to understand how I go from here to here. How do I do it? I write the Fourier transform of this one. 1 over 2 e to the power j0 plus 1 over 2 e to the power j0 or 1 times e to the power minus j omega times 1, right? Minus 1. This minus 1 comes here. Z'sini yazarsak ne olur? Z, h of z, 1 over 2 plus 1 over 2 z to the power minus 1, değil mi? So if this is my impulse response, I can write the transfer function like this, 1 over 2 plus 1 over 2 z to the power minus 1. If I want to write frequency response, then it is going to be 1 over 2 plus 1 over 2 times e to the power minus j omega. Şimdi ne yapacağım o zaman? I'm going to take the 1 over 2 parentheses, write 1 plus e to the power minus j omega, then find the number in between, and I'm going to keep it as my j omega over 2, 1 over 2, as my parentheses, in front of the parentheses. Then I'm going to write j omega over 2 plus e to the power minus j omega over 2. Arkadaşlar, I talked to you about that many times. I hope you remember how we go from here to here. Then what did we say? This 1 over 2 will be here, and this is going to be cosine omega over 2. And this is going to be this one. Takip edebildik mi gençler? Şimdi ben sizden ne istiyorum biliyor musunuz? If I give you h of n like this, one over 2, 0, 1 over 2. Can you find the frequency response?